Hey guys, this is Ryan,
I'm Cole.
I'm Zeke.
and this is our second lab video over experiment number 5, which is studying chemical reactions. And yeah, we're going to get started here real soon.
Hi guys, the purpose of this experiment we done the other day is to observe the many chemical reactants that are out there and to see if their products are soluble or insoluble.
Yes, that is true. That is what we are doing today. And some fun facts about this lab are that when chemical reactions occur, substances called reactants are transformed into the products that might have different appearances or properties as the reactants had, such as a colorless product or reactant going to a yellow product. Trying to observe these transformations may be easy at times, but at others it's very hard to see with the human eye. And to develop this skill of observation is very, very handy for chemists or just very specific scientists. Chemists represent chemical reactions by equations, element symbols, and formulas. And chemical equations are used to represent both the descriptive aspects of chemistry as well as the quantitative aspects as well.
Alright, so for part A, what we did is we took two compounds, one of them being potassium hydroxide and the other one being zinc sulfate, and we got 5 drops of each one in a test tube, and we reacted them together to see what would happen. And upon the reaction, we saw that the mixture combined into a yellowish liquid, and that's about all it did. We didn't really see any gas or precipitate, but it did turn yellow, so that's evidence of a chemical reaction. For part B, we took pure metals zinc, magnesium, and copper. We put them in a test tube, and we reacted them with solutions copper sulfate, magnesium sulfate, and hydrogen sulfate. And when the copper sulfate reacted with the zinc went from a light gray to a blackish color. And copper sulfate and magnesium, the solution was greenish with a visible precipitant forming, and that indicates a chemical reaction. When magnesium reacted with copper, however, there is no evidence at all of a chemical reaction. There is no bubbles indicating gas or any precipitant forming or color change. But when magnesium, sulfate, and zinc reacted together, a precipitant was present and it was a very cloudy solution. When zinc SO4 again reacted with copper, there is also no chemical reaction. But when zinc sulfate and magnesium reacted together, a gas was formed with bubbles, and that's an indication of a chemical reaction. Hydrogen sulfate and copper, no chemical reaction. Copper has not reacted with any of the solutions it's been paired with. Hydrogen sulfate and magnesium, however, the magnesium dissolved and a cloudy precipitant formed, and there was also a bubbly gas. Hydrogen sulfate and zinc, there was a black solution with a precipitant and a gas formed, and those are all 3 indications of a chemical reaction. In part C, when we reacted magnesium with hydrochloric acid, what we did was we took about a 1/2 centimeter long magnesium strip and we put it in the bottom of the test tube, and then we got 2 milliliters of a 0.1 molarity hydrochloric acid and we put that in a graduated cylinder. The magnesium strip was dark grayish in color and the hydrochloric acid was colorless, but when they reacted together, a gas emerged indicating a chemical reaction. And once you look at the balanced chemical equation of this reaction, it becomes evident that the reaction type is single replacement. When we reacted lead nitrate with potassium iodide, we put 10 drops of the lead nitrate solution in a test tube, and then we got 2 drops of the potassium iodide solution and put that into the test tube containing the lead nitrate. And initially both the solutions were colorless, but once they reacted together, the solution turned yellow, a gas evolved, and a precipitant formed. And when you write out the balanced chemical equation for this type of reaction, it is synthesis. And that is what we did for potassium iodide and lead nitrate. We heated the ammonium carbonate. We transferred a microspatule full amount of the ammonium carbonate, and it looked like a white solid powder. And then we got red litmus paper, placed it on a watch glass, and moistened it. And once we wet it with the water, it turned into a darker shade of red. And then we placed the tube containing the ammonium carbonate solution over a Bunsen burner, and the solid evaporated and condensation appeared on the walls of the tube. We then fanned the fumes over our nose, and the odor smelled like sulfur, and it was very strong. When we put the mouth of the tube to the litmus paper turned blue as soon as it was next to the mouth of the test tube. And when you write out the chemical reaction for this, the balanced chemical reaction for this equation, you learn that the reaction type is decomposition. When we reacted the iron chloride with the sodium hydroxide solution, we put 1 milliliter of the iron chloride solution in a test tube, and then we also put 1 milliliter of the sodium hydroxide solution in another test tube. And before we mixed them together, the iron chloride was orange, and the sodium hydroxide was pink. And once they were reacted together, the solution was orange, and it was very thick and cloudy, and you really couldn't see through it at all. And when you write out the balanced chemical reaction for this equation, you learn that the reaction type is a synthesis reaction. When we reacted the iron chloride with the sodium hydroxide solution, we put 1 milliliter of the iron chloride solution in a test tube, and then we also put 1 milliliter of the sodium hydroxide solution in another test tube. And before we mixed them together, the iron chloride was orange, and the sodium hydroxide was pink. And once they were reacted together, the solution was orange, and it was very thick and cloudy, and you really couldn't see through it at all. And when you write out the balanced chemical reaction for this equation, you learn that the reaction type is a synthesis reaction.
In conclusion to this video for experiment number 5, in part A, we mixed 2 chemicals together, which were what, Zeke?
They were potassium hydroxide and zinc sulfate.
Yeah, and they formed a yellowish substance.
In part B, like Zeke said earlier, there was a lot of reactions that happened. Every single one had a successful reaction, except for when all of them mixed with copper, which was a colorless solution, and no precipitate or anything formed whatsoever.
In part C, we mixed various chemicals together, and it produced lots of reactions. We saw color changes, we saw gases form, we saw precipitants form, and when we wrote the balanced chemical equations of these reactions, we were able to see what type of reaction it was. We had synthesis, we had decomposition, we had single replacement. Overall, it was a pretty successful experiment.
All right, there you go, guys.
There you go. That's it.
Woo!
See.
Hey guys, it's Ryan.
It's Cole.
Gee.
Hi guys. The purpose of this. God bless. That's.